In this lecture, we will discuss in more detail about the stress strain curve. Stress strain curve is actually give us information about the material, that how the material is response to external force. So if we apply the external force on the material such as the metal, the metal different metal will have different response to external force. So if we apply the stress, and the material stress is actually the force per unit area. So if we make the sample, the metallic sample, and that metallic sample will have some area, and if we exert the force on that area, so the force per unit area is called the stress. I mean that if we apply the stress on the material, there will be the strain occur in that material. So different material have different nature. It means that if we apply the force and different material, so their response to external force will be different. So the stress strain curve give us information about that what is the response of the material to the external force. Okay, so for that we use this machine, which is called the universal testing machine. In this machine we put that sample of the metal that we are going to determine their properties, that how much and what is the nature of that material. In other words, we can say that how this material is response to external force. Okay, so this material is this machine is used to apply the external force on that material, and here these two collimeter is applying the external force on this sample. This is actually that sample, and this is the simple diagram of this. So here we have this sample, this is the specimen sample, and this is fixed on both ends, and this machine is exert force on this sample. And due to if this machine exert the force on this sample, and that force is increasing, and a time will reach in which this sample become break. So and on the other hand, there is a computer, and the computer give us this graph. So this graph is called the stress strain curve. This graph give us the full information about that material, that how it is response to external force. Okay, so the external force per unit area is called the stress, and if we apply the stress on the sample, there will be some changes occur in the length of that sample. Okay, so that changes is called the strain. So from here, from this graph, we conclude that if we apply the force, if we apply the stress on this sample, there will be some elongation occur in this sample. Now, in other words, we can say that if we apply the perpendicular force on this sample, so this sample is made up of the large number of atoms. Okay, and that atoms are arranged in the crystal form. Okay, so the crystal will have some layers in that crystal, and if we apply the external force, that as a whole, that layer will be moved away from the lower layer of the crystal. So the bond between the atoms will be stretched. So if we apply the external force, that bonds between the atoms will be stretch, and their length will be increased, and as a whole the length of this material will be increased. So if we remove that force, external force, that atom will be again come to its original position. I mean that in this region of the graph, if we apply the stress on the material, the strain will be increased. But if we remove the stress, and this sample, the atoms will come to its original position. It means that the length of the sample will be the same as the original length. In this region, the material follow the Hooke's law. Hooke's law is actually the stress which is directly proportional to the strain at constant elastic modulus. From position A to B, the if we apply the less stress, the strain will be more. And here this B is called the elastic limit. In this region from A to B, the Hooke's law is not valid. Okay, stress is not directly proportional to strain, because the stress, if we increase the stress, if we apply the stress, the strain will be more as compared to a stress. So the Hooke's law is not valid from A to B. But if we remove the external force, the atoms will still the sample will still come to its original position. Mean that here still the sample is elastic. Okay, so up to here the sample is elastic, and this B is the last limit for the elasticity of the sample. So beyond this B, the material will be not elastic. So this B is called the elastic limit or yield point. Okay. So now beyond the point B, the atoms are stretched so higher that it do not come to its original position, and there is no proportionality between the stress and strain. So we call the region beyond this B as a plastic region. Plastic is those region in which the material do not regain its original shape when the external force has removed. So up to point B, the material is regain its shape, but beyond this point B, the material do not regain its shape. So we call this region beyond this point B as a plastic region. At this point C, which is called the ultimate strength, the nick is creating in the sample, and beyond this point C, that nick is will be increasing, and at point D, this sample become break. So in this linear graph, this actually represent this scenario. So this is actually that sample. If we exert the external, if there is no external force, this is the arrangement of that atoms. So if we apply the external force on this material will be elongated. Okay, and their width has decreased and their length has increased. Okay, and this is actually the atoms here, the bonds between these atom has stretched. Okay, so this is their stretch bond, and if we remove that external force, this sample again come to its original length. Okay, and its original diameter. So this is here actually the Hooke's law is valid. Okay, stress is directly proportional to strain within the elastic limit, and here the elasticity is also present. Now beyond this point up to point B, the material is still elastic. The material is still elastic, mean that if we remove the external force and if we apply the external force on this material, these planes will be slip over each other, and if this planes are slightly slip on each other, and if we remove the external force, this these atoms will again come to its original position, mean that still the material is elastic. Now beyond that point B, the material is plastic. So if we apply the external force, these these layer will be slip on each other, And if we remove the external force, these atoms will not come to its original position. Now, what is the stress strain curve? The stress strain curve show how a material responds when a force is applied and gradually increase. If we apply the force on the material and if we increase that force, then what will be the response of that material to the external force, and which is represented by this graph. So in this graph, this is the detailed explanation of the from the atomic arrangement of that material under the action of external force. This is the graphical analysis, and in this graph, from the position O to position A, okay, from the point O to point A, in this region from O to A, the curve is linear, meaning stress and strain are directly proportional in this region. This region follow Hooke's law, as I had discussed that if we apply the stress, if we increase the stress, the strain is also increasing, and this follow the linear relation, and this linear relation is discussed by the Hooke's law within the elastic limit. And here the material behave as an elastic body. Now, what is the physics behind the from point A to point B? So beyond point A, the stress and strain are no longer proportional. Mean that if we apply the less stress, there will be more changes occur in the strain of that material. However, the material still returns to its original shape when the force is removed. So the material is still is elastic. Okay. So up to here, up to point B, the this whole journey is for the elastic material. Now, the point B is called the yield point or elastic limit. So, this is the last limit for the elasticity of the material. So, beyond this point B, there will be no elastic nature of that material. Okay, so this point B is called the yield point or elastic point, and the stress at this position at this point B is called the yield strength. Okay, this stress is called the yield strength. Okay, now the what is the plastic region? So beyond this point B, the plastic region is initiating. So this B is the last limit of the elasticity. So therefore we call this as elastic limit. And so beyond this point B, the plastic plastic nature is will be begin. Okay, from this point B. Now if the stress beyond this point B is increased, okay, the material will not come to its original position. In this region, the strain increase significantly. So there is more changes occur in the strain of the material even if the stress is the small. Now it there must be some point C. So from point B to point C, the material will do not come to its original position if the external force has removed, mean that the material is now is a plastic material. So this point C, the material reach its ultimate strength, okay, which is the maximum stress it can bear. This is the maximum stress it can bear. So beyond this stress, there will be neck occur in the material. Okay, so this is that this is actually that stress which the higher stress which a material can bear. This point C is actually represent that. Now beyond this point C, Okay, the material undergo plastic deformation where it cannot return to its original shape if even if the stress is removed. Okay, so if we remove the stress beyond this point C to point D, the material will do not come to its original position. Okay, and there will be the permanent changes occur in this material, and this point at this point D, the material will be break. Now there are two types here. This stress strain curve is actually for two types of the material. One is the ductile. Okay, this is the ductile. This is the graph for the ductile material, and this is the graph for the brittle material. So here this if we increase if we apply the stress and the material, there will be change occur in the strain, and here the Hooke's law is follow up to here up to this point, and beyond this point the Hooke's law will not valid, but the material is still elastic, and here the breaking of the material will be occur, and this material is brittle. Now, the same case is present here. The Hooke law is follow up to here, and beyond this point, the Hooke law will not follow. And up to here, we have the elastic limit, and above, beyond that elastic limit, there still the changes occur in the material. So, still there is change occur in the strain of the material if the small changes occur in the stress of that material. So this graph, this red color graph is actually represent the ductile nature of the material.